Hello viewers, in today's class we are going to discuss one important concept in three-dimensional geometry, right? So here we are going to discuss one important problem, and the problem, it belongs to the concept of intersection of line and plane, right? So let us start. And here what we have to do, we have to find the point of intersection of the line and the plane, right? So here we are given the equation of the line L. We can take the line as L. So the equation is x minus 1 over 2, y plus 3 over 5, and z plus 1 over minus 1. And we are given the equation of the plane P, right? So here the equation of the plane is 3x minus 6y plus 2z plus 7 is equal to 0, right? So we have to find the equation, the point of intersection of this line L and this plane P, right? So let us draw a rough sketch of this problem. So this is the plane P. We can take this as plane P, and we can take the line like this, right? So this is the line, right? So here this is the line, and this point, let us take this point as Q, right? And this point Q is the point of intersection, right? Point of intersection of the line with the plane, right? So we have to find the coordinates of this point Q. So for this, what we will do, we'll make use of the concept of general point, general point on a line, general point on a line, right? So for this we'll make use of the equation of the line, and here we'll take lambda, right? So we can take lambda and we'll find out the coordinates of the general point lying on a line, right? So if we take this equation, then we have x minus 1 over 2 is equal to lambda, then we have y plus 3 over 5 is equal to lambda, z plus 1 over minus 1 is equal to lambda, right? So now we can solve these three equations for lambda or for x. So we have x is equal to 2 lambda plus 1, then we have y is equal to 5 lambda minus 3, and then we have z is equal to minus lambda minus 1. So now here x, y, z represents the coordinates of the general point on this line L, right? So for some value of lambda, we can have the coordinates of this point Q, right? So x, y, z is 2 lambda plus 1, 5 lambda minus 3, and minus lambda minus 1, right? So for some value of lambda, this point will represent this point Q, right? So now we see that when this line L, it intersects this plane P, then this point Q is a common point between this line L and P, right? So this point Q has to satisfy the equation of the plane, right? Because this point Q is the point of intersection of this line L and P, so Q is the common point between the line and P. Or in other words, we can say that Q lies simultaneously on this line L and P, right? So this point Q has to satisfy the equation of the given plane. So now for some value of lambda, we are taking this as the point Q. So this point must satisfy this equation. So now we can take x is equal to 2 lambda plus 1 here, y is equal to 5 lambda minus 3 over here, and z is equal to minus lambda minus 1 over here. So now we have 3 times 2 lambda plus 1, then we have minus 6, and 5 lambda minus 3, then we have plus 2 and minus lambda minus 1, and then we have plus 7 is equal to 0, right? So now this is a simple linear equation in lambda. We can solve it easily. So this is 6 lambda, this is 3 minus this is 30 lambda, here we have 18 plus 18, then we have minus 2 lambda, this is minus 2, and this is 7, right? And 6 lambda minus 30 lambda and minus 2 lambda is equal to minus 26 lambda, right? And 3 plus 18 is 21, and 21 plus 7 28, 28 minus 2 is 26, right? So now we have minus 26 lambda is equal to minus 26, and lambda is minus 26 over minus 26, so lambda is equal to 1, right? So once we have obtained the value of lambda, that is equal to 1, we can substitute lambda over here to get the coordinates of this point Q, right? So the coordinates of this point Q are given by, see here we have lambda is equal to 1, so we have 2 times lambda, that is 1, plus 1, then we have 5 lambda, lambda is 1, so we have 5 times 1 minus 3, and then we have minus 1 minus 1, right? So this is 2 ones are 2 plus 1 3, and 5 minus 3 is 2, and minus 1 minus 1 is minus 2, right? So viewers, the point of intersection of this line L and this plane P is given by 3 comma 2 comma minus 2. So 3 2 minus 2 is the point of intersection of this line L and this plane P.